All right, we're going to take a look at page 335, number 19. So you can go ahead and pause the video and read that if you want. All right, so in this one we have a wheel. It tells us it has a radius of 0.6 meters. It told us the diameter, but we converted it. It also tells us its angular velocity. Okay. Now, it asks us to find its linear speed of its center of mass if it is rolling. And if something's rolling without slipping, we remember that the velocity of the center of mass is equal to omega times r. So the velocity of our center of mass is going to be 0.6 times 3. And so we get 1.8 meters per second is how fast it is moving. Okay. Then it starts to ask us some other things, like what's the total kinetic energy of the hoop? Well, to get the total kinetic energy of the hoop, I need to do 1/2 mv squared plus 1/2 I omega squared. And I believe they did tell me the mass was 2.2 kilograms. And so we could plug in I for a hoop of mr squared. We know omega, we know mass, we know velocity. We can do this. Okay? And so our kinetic energy will come out to a number. Now, the second part is what I really want to kind of show you here. So if I have a wheel and it's just simply rotating, so here I have it rotating around. So positive or negative rotation. So slow it down here so the video picks up on it. So it's going clockwise, so that would be a negative rotation if I wanted to use my right hand rule. Curl my fingers around the axis of rotation, my thumb points in to the board. So yes, it's negative. So if I think about any point on the outside of that rim, it has a velocity. And so it has a velocity from the fact that it's rotating. Okay? Now, if I go ahead and just cause this to move, okay, it's not rotating, it's just moving linearly. All the points have the same velocity. Some velocity to the right. Now, if I let something roll, so not only is it rotating, but it's also moving. And so what we have to do then to get the overall velocity of any point on that wheel is we have to add those two velocities together. And so down here at the bottom, where it's rolling on the ground, you'll see that these two velocities cancel out and I get a velocity of 0. Where up here, where they're pointing together, I get a velocity of 2v. Okay? And over here, yeah, we get something that's kind of down and to the right. Up here, we get something up and to the right. Okay? But you'll notice I get this velocity of 0, and that makes sense for a rolling object. It's not moving relative to the ground at that point. The wheel is in contact with the ground, but not skidding on the ground. And so it has a velocity of 0 down there at the bottom. There is a diagram on your note packet right underneath this that kind of shows those being put together. The next video will be me working through the AP question. That's an example down below. But you do have some clickers to finish before that.